Okay, AP Statistics students, moving forward to Chapter 7 is our continuation of normal distributions. We talked about the sampling distributions of p hat and x bar in Chapter 7. If you have this population of interest, if you pull a sample out of that population of interest, and you do that many, many times, as long as certain conditions are met, the distribution of the samples will be normal, even if the population is skewed. So, if we talk about the sampling distribution of p hat on the left side of this slide, we say that the sampling distribution of sample proportions, p hats, can be considered normal if the sampling was done randomly or is less than 10% of the population. The expected number of successes n times p is greater than or equal to 10, and the expected number of failures n times 1 minus p is greater than or equal to 10. If those conditions are met, you consider that the distribution of p hat is normal, and therefore you can use normal CDF to calculate probabilities. The standard deviation of the sampling distribution of sample proportions is given by the formula square root of p times 1 minus p over n. You should be familiar with that formula because not only was it a part of Chapter 7, but it was also a part of Chapters 8, 9, and 10, so to speak. We also learned in Chapter 7 that the sampling distribution of sample means, x bars, can be considered normal if the sample was randomly chosen or is less than 10% of the population, and that the sample size is greater than or equal to 30. We also learned that if the population is normal, then the sample will automatically be considered normal. If you draw a sample out of a normal population, the distribution of the sampling will be normal. Okay. The standard deviation of the sampling distribution of sample means is given by the formula, the standard deviation of x bar is equal to s over the square root of n. So now remember, we expect p hat to equal p, and we expect x bar to equal mu. So you've got your mean and your standard deviations. So let's take a look at some sample questions. And as I work through a couple of these sample questions, I'm going to show you some of the mistakes that they expect you to make and to avoid them. Let's read this first sample problem. The distance Jonathan can throw a shot put is skewed to the right. Oh no, I can't use a normal distribution. No, be careful. With a mean of 14.2 meters and a standard deviation of 3.5 meters. Over the course of a month, Jonathan makes 75 throws. Assume these throws can be considered a random sample, of Jonathan's shot put throws. Well, because the throws are a random sample and 75 is greater than or equal to 30, then we can consider using a normal distribution to answer this question. What is the probability that Jonathan's average shot put distance for the month will be over 15 meters? Well, let me show you what they're expecting someone to do mistakenly. It's a multiple choice question, so I'm not going to show my work. I'm just going to say, what is the probability that Jonathan's average is over 15? So they expect somebody to pull up normal CDF, 15 for the lower bound, big number for the upper bound, and then the mean is 14.2, and the standard deviation is 3.5. And so let's see, we're going to grab the calculator and actually type this in. So menu, statistics, distributions, normal CDF. Let's see, 15, upper bound, big number, mean 14.2, and the standard deviation 3.5, and okay. I notice that this answer is 0.409, and I'm noticing that answer choice B matches that very well. And so you sit here thinking, I've done this problem correctly. Well, you see, the mistake is this. This standard deviation of 3.5 is not the standard deviation of x bar. This is the standard deviation of each throw. So you just found what is the probability that one of Jonathan's throws will be longer than 15 meters. That's what this 0.409 says. It's a 41% chance that any one of his throws will be over 15 meters. Well, that's not what was asked. The question that was being asked is what is the probability that the average of his throws will be over 15? And that would be normal CDF 15, comma big, comma the mean and standard deviation of the average x bar. So the mean of x bar is equal to mu. Well, that's still 14.2. So it was okay to put 14.2 right there. But here's the big deal. The standard deviation of x bar is equal to s over the square root of n. Well, that's 3.5 over the square root of 75 throws. So I need to calculate 3.5 divided by the square root of 75 is 0.404. So instead of putting 3.5, the standard deviation of each individual throw, I want to put 0.404, the standard deviation of the average. So now let's press menu and go down to statistics, down to distributions, normal CDF, lower bound 15, upper bound some big number, the mean 14.2, and the standard deviation 0.404, and say okay. And now the calculator tells me 0.023 is the correct answer. And so it's actually answer choice A. B was there to distract you. B is the probability that any one of his throws would be longer than 15 meters. A is the probability that the average of 75 throws will be over 15 meters. So you got to know the difference. Heights of fourth graders are normally distributed with a mean of 52 and a standard of 3.5. For a research project, you plan to measure a simple random sample of 30 fourth graders. For samples such as yours, 10% of the samples should have an average height below what number? So let's see. In a distribution of fourth graders' heights with a mean of 52, 10% of the samples should have an average below what number? Should have an average below what number? So here's the mistake. The mistake that somebody's going to make is they're going to do inverse norm 0.10 comma 52 comma 3.5. And they're not going to realize they're wrong because it's wrong to put the 3.5 right there, because that is the standard deviation of one fourth grader's height, the standard deviation of each fourth grader's height. Well, what is the correct way to solve this problem? Inverse norm 0.10 comma 52, no problem there, but we got to put the right standard deviation right there. We need the standard deviation of x bar because this problem was about 10% of would have an average height below what number? So then that's going to be 3.5 divided by the square root of 30. So if I take 3.5 divided by the square root of 30, I get 0.639. So if I put 0.639 there instead of the incorrect 3.5, I'm going to get the correct answer. So menu, statistics, distributions, inverse normal, 0.10 area. Let's see, 52 for the mean and 0.639 for the standard deviation. And I get 51.18. So then that would say that B is the correct answer. Well, if I go over to this wrong one, let's see, menu, statistics, distributions, inverse normal, 0.10, 52, and I put in a standard deviation of 3.5, I get 47.51. Not realizing it's wrong, notice that it's an answer choice. That is wrong. So you got to understand the difference between whether they're asking you for the percentage of the distribution of individual values or if they're asking you for the percentage of the distribution of a mean, and use the right standard deviation formula. I'll leave these problems to you. You can pause, copy them down, and do them, and ask me to check them, but it should be very much the same, but let's just skim over them. The distribution of scores for persons over 16 years of age on a common IQ test is normal with a mean of 100 and a standard deviation of 15. So notice that this first one says, what is the probability that a randomly chosen adult has an IQ score on his test over 105? Would that be normal CDF 105, big number for the upper bound, 100, 15? That would be correct, because you see this standard deviation of 15 is the standard deviation of the individual scores of the IQs. And since this is what's the probability that a randomly chosen adult, then 15 is the right standard deviation. Part B, what are the mean and standard deviation of the IQ score on this test for a simple random sample of 60 people? So they're asking you for what is the mean of X bar. Well, remember the mean of X bar, the expected value of X bar, is what the population is. The standard deviation of X bar is S over the square root of N, so 15 over the square root of 60. So we have 15 divided by the square root of 60 is 1.94-ish. And then you read part C. What is the probability that the average IQ score on this test of 60 randomly chosen people is 105 or higher? That would be normal CDF 105, big number, 100. And you see at this point, it seems like they're asking you the exact same question as part A, but they're not. Part A was, what is the probability that one randomly chosen person's IQ is over 105? And so the standard deviation to use is 15. But here they're saying, what is the probability that the average of 60 people's IQ scores is 105 or higher? It would be a mistake to put 15 here, because you have to put the standard deviation of the mean here to be correct. And so let's get that answer. Menu, statistics, distributions, normal CDF, 105, big number for the upper bound, 100, and 1.94. And so that's 0.005. So that answer would be 0.5% chance. This answer would probably be much bigger, back up to the top, okay? All right, so hopefully you see the difference between those types of problems. Here's one last example. Suppose it is known that 43% of Americans own an iPhone. P equals 0.43. If a random sample of 50 Americans were surveyed, what is the probability that the proportion of the sample who owned an iPhone is between 45 and 50%? Okay, well, we have to check the conditions for normality if this is a free response question. So let's see the conditions for normality. The 50 Americans were randomly chosen. Okay, and N times P is 50 times, we would expect 43% of them. So let's see, 50 times 0.43 is 21.5. If we randomly chose 50 people, we would expect about 21 to 22 of them to own an iPhone. N times 1 minus P is 50 times 0.57, excuse me. And so 50 times 0.57 is 28.5. If we randomly selected 50 people, we would expect 28.5 of them to not own an iPhone. The conditions for normality of P hat are met. And so now I can justify my work, if this is a free response question. What is the probability that P hat is between 0.45 and 0.5 is the question. And let's see, the mean is 0.43, and so we're looking for the shaded area between 0.45 and 0.50 to answer this question. Okay. Oh, by the way, I need to have defined P hat. Let P hat equal the percentage of Americans who own an iPhone. I can't say this without having first defined P hat. Well, you know that you're going to call up normal CDF, and you know you're going to put 0.45 as the lower bound and 0.50 as the upper bound and 0.43 as the mean, but you have to have a standard deviation to put in as that fourth number. The standard deviation of P hat is the square root of P times 1 minus P, that should be 0.57, divided by the sample size, and that was 50. So let's see, 0.43 times 0.57 divided by 50. Don't forget to take the square root of that. And I get 0.07. So now I know 0.07 goes in there. So now I'm pressing menu, statistics, distributions, normal CDF, 0.45 lower bound, 0.5 upper bound, 0.43 mean, 0.07 standard deviation. Calculator spits out 0.23. This is 0.23. Write a complete sentence. There's about a 23% chance that a random sample of 50 Americans would show that between 45 and 50% of them own an iPhone. So make sure you write that sentence if you're in a free response setting. Okay, hopefully this helps distinguish between the normal distributions from Chapter 2 and the normal distributions of P hat and X bar from Chapter 7.